Today we're learning about reference angles. You should have in a previous video learned about what a coterminal angle is, what a terminal side is, standard positions, so on and so forth. So now today we're going to take it one step further and talk about what a reference angle is. So in the first section, our example is draw a 60-degree reference angle in each quadrant, which may or may not be on your paper, so make sure that it's listed there so that you have a copy. And we're going to start off by literally drawing a 60-degree angle. So in this quadrant, in the first quadrant, as a review, this is the first quadrant. Right here is a 60-degree angle. Now in the other quadrants, we're still going to have a 60-degree angle. So this is quadrant 2. This is a 60-degree angle right here. But now that's a 60-degree angle in quadrant 2. Now, there's other ways that we can measure that as well. What you should have learned in a previous video is that if we measure to the terminal side, this is actually 120 degrees. So even though it's a 120-degree measure, we have a 60-degree reference angle in quadrant 2. Same applies for quadrants 3 and 4. So quadrant 3, there's our 60-degree reference angle, and quadrant 4. Oops, 60 degrees. And that should have been a blue line. This is actually a 300-degree measure. Then I forgot to do the one back here. If you want to measure this whole entire way to the terminal side, that's actually 240 degrees. So ultimately, reference angles, if you look at the definition, it says associated with every angle drawn in standard position, there's another angle called the reference angle, which is what we just drew. The reference angle is the acute angle formed by the terminal side. So for example, right here, terminal side, terminal side, terminal side of the given angle and the x-axis. Reference angles may appear in all 4 quadrants, which is what we just referenced. Angles in quadrant 1 are their own reference angles. So as you could see in our quadrant 1, we just had a 60-degree angle. Now we can sometimes call these bow tie angles. And here's why. So if we create that 60-degree angle in every single quadrant on the same exact axes, we're going to have something that looks like a bow tie. So we have our little bow tie, something that we would put on our paper, on our necks, right? And we have a 60-degree angle in each quadrant. You call creating these reference angles dropping a perpendicular. That's going to be important for later. So dropping a perpendicular just means that once I've created my angle, I drop it straight down to the x-axis. And when you create reference angles, you have to be careful that you're dropping them to the x-axis and not to the y-axis. So reference angles are measured from the terminal side of the angle to the x-axis or horizontal. So I put my line down to the x-axis here. I did not put it to the y-axis. So ultimately, that is what reference angle is. So at the bottom, we have a couple of examples of how you might see that. So in the first one, the reference angle theta. So let's draw theta. We have theta is 120 degrees. We know from previous videos and above that this angle right here is 120 degrees. But we are looking for the reference angle. And a reference angle is often called theta prime. So that's called theta prime, which is just a theta with a little apostrophe. So we're looking for theta prime, and let me choose a color. I drop a perpendicular. It's perpendicular here. And right in here is theta prime. Now, how would we figure out the angle measure? Well, we could take, what's this whole thing? 180 degrees, right? So 180 degrees minus my angle, which is 120 degrees. And that gives me 60 degrees. So this angle is 60 degrees. Theta prime is 60 degrees. And that's the same exact degree measure we saw up top. Now we're actually going to look at a couple different ones. So in number 2, we have theta is negative 135 degrees. And so I'm going to draw my angle. If it's negative, that means I have to measure clockwise, not counterclockwise. So this is my angle, 135 degrees. And if I am dropping my perpendicular, I'm dropping it up this time, not down, but I'm still making it to my horizontal axis. So my measure in here is what we're looking for. And that will be my theta prime. To figure out this angle, it's still 180 degrees, so I'm going to take 180 and subtract my 135 degrees, which is 45 degrees. So this measure in here is 45 degrees. I'd like you to work on these two, see what you can do. I will help you out by drawing the measures. So in this first one, we have a 208 degree measure. And if I'm dropping a perpendicular, again, I'm dropping it up. So I'm dropping it up to my horizontal, and I'm looking for theta prime, which is right in here. You can finish off number 3, and I want you to see if you can figure out number 4. Come to me with those next class so that we can go over them. But for now, we do have a couple things on the back that I'd like you to talk about. So, and the bell rang once, so expect a second one, unless we finish up before then. So number 5, we have name all 4 angles from 0 to 360 degrees with the given reference angle. So in number 5, we are told that we have a reference angle of 25 degrees. So I'm going to start off by creating my first one. And that is 25 degrees. And remember, a reference angle in the first quadrant is just itself. It's 25 degrees. So I'm going to list quadrant 1 at 25 degrees. Now quadrant 2, make our bow tie, at least part of it. This will also be 25 degrees. But I need to figure out what the measure is from the beginning to the end. So to my terminal side. So quadrant 2, I have to take my whole 180 degree measure and subtract from it my 25 degrees to get how much is to the red. So 180 minus 25 degrees will get you 155 degrees. So the red is 155 degrees. We have quadrant 3. So I'm making my 25 degree angle, my reference angle. But now I need to measure all the way around. I still drop my perpendicular to the 180 degree line, but now I have to add 180 degrees to 25 degrees because it's a little bit more than 180 degrees. 180 plus 25 gives me 205 degrees. So all of that blue is 205 degrees. So we've done 3 quadrants. We have 1 remaining quadrant left, and that's quadrant 4. So starting over here, I don't really have much room. Well, I'll draw my angle first. So this is my reference angle of 25 degrees in the 4th quadrant. And really, that means I'm coming all the way around. You don't have to draw this if you don't want to. And I'm trying to figure out that measure. Well, if I drop a perpendicular, I'll be dropping it up to this axis, which is 360 degrees. So really, I'm taking 360. And it's not quite 360, you have to subtract 25. So minus 25 degrees. 360 minus 25, that's 335 degrees. My suggestion for these problems, if they're asking for all of those angles, is to start off by making your bow tie in each of the quadrants. So if we wanted to do number 6, start off by making 36 degrees. So I know that this is 36 degrees all the way around, and I just have to do the math after that. Set it up the same way, Q1, Q2, Q3, and Q4. So in Q1, it's always the reference angle that they give you because it's its own reference angle. Q2, there's the second bell. Q2, I'm taking my 180 because if I drop a perpendicular, it's going down to this 180 degree line. So 180. But this one's a little less. So 180 minus 36. That's going to give me 144. Quadrant 3, I'm down here, I have to take 180 and add a little bit to it, which is 36. So 180 plus 36, just 260. And finally, my last one. So if I'm almost at 360, I have to take a little bit away. So 360 minus 36 degrees, which is 324 degrees. I'm going to let you guys do numbers 7 and 8. We'll go over that next class. And now we have 2 more that I do want to talk about with you, and that's numbers 9 and 10. Move it up. So in number 9, this is actually going to take a little bit of work. And they give me that there's a 30-degree reference angle. Remember, theta prime is 30 degrees. Find the coordinates of the points on the unit circle corresponding to quadrant 2, 3, and 4 with this reference angle. So start off by making your bow tie. 30, 30, 30, 30. So I know this is 30, this is 30, 30, 30. I'm going to drop my perpendiculars. And really this is on the unit circle, right? Because it says the points on the unit circle. So even though this is going to look terrible, I'm going to try and make it look like I'm kind of on the unit circle. So what do you notice? Well, I kind of have a triangle right here that looks like a 30, 60, 90 triangle. So if I have a 30, 60, 90, remember this angle right here is my 30, that means that's 60. And it's a unit circle, which means that my radius is 1, which means my hypotenuse is 1. We solved for this before, so let's solve for it again, just in case you've forgotten. We have 30, 60, 90. N and root 3 and 2n are my ratios. And I'm filling in what I know. So I'm going to call this right here my x, because that's how far it would be going over. Y, because this is my x-axis, so I'm going over x and up a certain amount, y. So opposite of 30, y. Opposite of 60, x. Opposite of 90, 1. Let's figure out what our sides are. So I have 1 is equal to 2n. Divide both sides by 2. You get n is 1/2. Which means that my y is 1/2. And that my x is 1/2 times the square root of 3. Or you can write it as the square root of 3 over 2. Okay, we know what these are, so that means I can go back and put my little points, my coordinate pairs, on my unit circle. In the first quadrant, I go over, so positive, I go up, positive. So that means I'm going over x, which is square root of 3 over 2. And I'm going up y, which is 1/2. Now in quadrant 2, I'm going left, which means my x coordinate has to be negative, so negative square root of 3 over 2. And y is going to be positive 1/2. In the third quadrant, I go left, which is negative, and I go down, which is negative. But it's the same, since it's the same reference angle, it's the same coordinate pair in every single quadrant. It just changes signs based on our all students take calc, our ASTC. So in the first quadrant, positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. And in the fourth quadrant, I go right, which means my x coordinate's positive, and my y coordinate is negative, but still the same exact coordinate pair. So did we answer the question? We figured out what the coordinates of all the points on the unit circle are for our reference angle of 30 degrees. Number 10, I'm going to ask you to do as well. You have to do less work, actually, because you don't have to come up with your special right triangle. I'm going to start you off by making your sine of 18, so that means I have a reference angle of 18 degrees in every quadrant. That's a pretty tiny angle. We can drop our perpendiculars. we have 18, 18, 18, and 18. So you are looking for these 4 points. And they give you the first one in quadrant 1. So we have cosine is 0.951. Cosine is x, sine is y. So cosine is 0.951, comma, sine, which is 0.309. So take what you know about quadrant 1 and apply it to the other 3 quadrants. 162, 198, and 342 are the same reference angle of 18 degrees. Alright, go back, go through and finish up those questions that I asked you to do. Come with them next class and we will go over them. Alright, thanks guys.